Hi everyone, and good day to you all. So today we'll be having a class on physics from 4, chapter 4, heat, and I'll be focusing mainly on subtopic 4.1, thermal equilibrium. So before we start our lesson today, I would like to introduce me, myself, and also my partner. My name is Uiwanting and I'm from SMK Perempuan Methodist Ipoh, and my partner is Aiman from Sekolah Tuanku Abdul Rahman. Okay, so let's begin our lesson today. What are heat and temperature, and what are their differences? So, as you can see here, the table here, heat is a form of energy. For example, like the heat sources, the fire sources, and temperature is a measure of the degree of hotness of an object. So, for example, you can know the temperature of a liquid or an object by using a thermometer. And after that, heat is a derived quantity, while temperature is a base quantity. In case you have forgotten, derived quantity and base quantity are both physical quantities. Okay, so derived quantity is a physical quantity that is obtained from combining one or more base quantities through the operation of multiplication or division or the both operations. And for base quantity is a physical quantity that cannot be derived from another physical quantity. After that, the SI unit for heat is joule, which is a capital letter J, and SI unit for temperature is Kelvin, which is a capital letter K. Okay, now, what is thermal equilibrium? Thermal equilibrium is a situation that occurs when two objects are in a thermal contact. What is thermal contact? Thermal contact is a physical connection between two bodies that allows for the transfer of thermal energy from a body with a higher temperature to a body with a lower temperature. So it means that, for example, like there are two liquids, one hot and one cold. They are in a physical connection. Therefore, there is a transfer of heat energy from a body with a higher temperature to the body with a lower temperature. For example, the the heat will transfer from the hot object to the cold object. Yeah, let's continue. The temperature of the hot object will drop while the temperature of the cold object will rise until the temperature of both objects become the same. And the net heat transfer between the two objects becomes zero. Okay, so if there is a question that asks what is thermal equilibrium, you have to include these few keywords in your answer. Like the, for example, like the two objects are in the thermal contact. And then you have to say that what happens to the temperature of the hot object and also the temperature of the cold object. So the temperature of the hot object will drop and the temperature of the cold object will rise. And you have to mention what will happen to the temperature of both objects at the end. So the temperature of the objects will become the same. And you have to include the net heat transfer also. It will become zero. So here's a little conclusion for the condition of thermal equilibrium. So therefore, when two objects are in thermal equilibrium, the both objects will have the same temperature, the same final temperature, and they will also have the zero net flow of heat. Okay. What will happen when both objects are in thermal contact? So we can observe the diagram here. You can see that there is two objects, object P and object Q. Okay, so object P, you can know that it is a hot object because you can see the temperature here. It shows 100 degrees Celsius, And for object Q, it is around 30 degrees Celsius because it's between 20 degrees Celsius and 40 degrees Celsius. And also, you can observe the arrows here, the heat transfer. You can see that the heat transfer from the object P to Q has a bigger arrow, and from object Q to P has a smaller arrow. But why? Let's see. So in the beginning, the rate of heat transfer from the hot object P to the cold object Q is higher than the rate of heat transfer from the cold object Q to hot object P. Why is the rate of heat transfer from hot object P to cold object Q is higher from the cold object to the hot object? It's because when the both objects are in the thermal contact, there's the heat transfer between them, and it's from a object with a higher temperature to an object with a lower temperature. And there's a net transfer of heat from the hot object to the cold object. And at the middle stage, you can see that the temperature of P drops while the temperature of the Q rises. So just now the temperature of object P was 100 degrees Celsius, and it has dropped to around between 75 to 80 degrees Celsius. And for object Q, the temperature has rises from the 30 degrees Celsius to the 40 degrees Celsius. Okay, so you observe the arrow here. The heat transfer from the P to the Q, the arrow has decreased in size, and the heat transfer from Q to P has increased in the size of the arrow. Okay, next. And at the end, the temperature of P and Q become the same, and the rate of heat transfer from P to Q and the rate of the heat transfer from Q to P is the same. And the net heat transfer between P and Q becomes 0. So P and Q are now said to be in a state of thermal equilibrium. Now we observe the diagram again. So P and Q, you can see that they now have the same final temperature, which is between 50 to 60 degrees Celsius. And the arrows are equal to the size of the arrows. It means that the heat transfer from P to Q and the heat transfer from Q to P is equal now. Okay. Now, I would like to explain the types of thermometer. So there are many types of thermometer, but today I'll be explaining one of the type, which is the liquid in glass thermometer. For a liquid in glass thermometer, there are two examples, which are mercury and also alcohol thermometer. What are their differences? Mercury thermometer has a high boiling point, which is 357 degrees Celsius, and alcohol thermometer has a low boiling point, which is 78 degrees Celsius. And next, mercury thermometer has a higher melting point compared to alcohol thermometer, which is the negative 39 degrees Celsius. And the alcohol thermometer has a lower melting point compared to mercury thermometer, which is negative 115 degrees Celsius. So after that, mercury thermometer is a good heat conductor, and alcohol thermometer is a poor heat conductor. Now, I'd like to explain something. So when you see here, alcohol thermometer has a lower melting point, which is negative 115 degrees Celsius. If it has a lower sorry, wait. So it has here, the alcohol thermometer has a lower boiling point, which is 78 degrees Celsius. It means that it cannot measure a higher temperature like compared to the mercury thermometer, which has a higher boiling point. And for the lower melting point, the alcohol thermometer can measure a lower temperature compared to the mercury thermometer. Next, mercury thermometer, it expands uniformly and rapidly. If the mercury thermometer expands rapidly, so it means that it gives out results quickly, so you get to know the temperature of a liquid faster. And for alcohol thermometer, its expansion is slightly irregular. Besides that, mercury thermometer, it does not wet glass. What does it mean by it does not wet glass? It does not wet glass means that the mercury in the thermometer, it does not stick to the wall of the capillary tube. And for alcohol thermometer, it wets glass, means that it will stick to the wall of the capillary tube. And if the mercury thermometer does not stick to the wall of the capillary tube, so we can get a higher results that can be highly accurate. Yeah. And lastly, mercury thermometer is opaque. What is the meaning of opaque? Opaque means is not transparent. As you know that mercury is silver, so it is opaque, and so therefore we can observe easily and get to see the results clearly. And for alcohol thermometer, it is transparent, and therefore the alcohol has to be colored to make it visible. For example, sometimes you can see the alcohol thermometer, the alcohol inside the thermometer is red in color. It means that the alcohol has been colored. Now, there are two past year SPM questions that are related to the topic that I would like to discuss with y'all. And I have a 4 marks structure question and also a 10 marks essay question. I would like to start with the structure question first, and it is taken from SPM to year 2013. Now, let's read the question first. Diagram 1 shows a thermometer is used to measure the temperature of hot water. In the diagram, we can see that the thermometer is immersed in a beaker that is filled with hot water. Okay, so the thermometer, we need to use it to measure the temperature of the hot water. So the first question, name one type of liquid used in the thermometer. So the keyword here is the type of liquid. So I've explained the type of thermometers just now, which is the liquid and glass thermometer, and there are two types of liquid used, which is mercury and alcohol. So which type of liquid is suitable to be used in a thermometer? Does anyone knows the answer? You can type out in the chat. Yeah, mercury thermometer is correct. So now let's look at the second question. Give one reason for the answer in 1A1. So why do we use mercury in our thermometer? So the answer for this question, you can take from the characteristics of the mercury thermometer. So the answer is you can say that mercury has a high boiling point, it is a good heat conductor, it expands uniformly and rapidly, and also it is opaque, which means that it can be clear, easy to be seen. Okay, now let's move on to B1. Complete the following sentence by taking the correct answer. The temperature of the water is taken when the liquid in the thermometer starts to expand or stops expanding. So can someone tell me the answer? You can type in the chat. Yeah, the correct answer is stop expanding. But why do we have to take the temperature when the liquid in the thermometer stops expanding? It is because it is related to our subtopic today, which is thermal equilibrium. So when liquid in the thermometer stops expanding, it means that the thermometer and the water have reached the thermal equilibrium, and the thermal equilibrium occurs when the thermometer and the hot water are the water are the same temperature, and there is no net heat transfer between them. The net heat transfer has become zero. So when you want to know the temperature of the water, you take the temperature when the liquid in the thermometer stops expanding. Because the the water and the thermometer has the same final temperature, so you can know the actual temperature of the water. Okay, the second question. Name the physics principle involved in 1B1. Can anyone share your answer? Yeah, the correct answer is thermal equilibrium. Now, let's move to the essay question, and it is from SPM year 2003. The question is, you are representing the country in carrying out a research project on the weather at the North Pole. So you know that the North Pole is really extremely cold, and the surrounding temperature is between the negative 40 degrees Celsius to the negative 8 degrees Celsius. One item of the equipment to be taken for your research is a thermometer. So from this question, you know that we need to do a research at the North Pole, and the North Pole has a temperature between negative 40 degrees Celsius to the negative 8 degrees Celsius. It means that the North Pole has the lowest temperature, which is negative 40 degrees Celsius, and its highest temperature is negative 8 degrees Celsius. And to carry out this project, this research project, we have to use a thermometer. Based on the table in the next slide, explain the suitable characteristics of the thermometer so that it can be used to measure the temperature at the North Pole, and decide which thermometer is most suitable to be taken for your research, and give reasons. So we need to choose a most suitable thermometer that can be used at the North Pole, that can function well at an extremely cold place. So let's see. The table shows the characteristics of 6 types of thermometer: P, Q, R, S, T, and U. So there are a few types of characteristics here. The liquid used is either mercury or alcohol, and the glass bulb used is thin or either thick. Capillary tube has a diameter which is either big or small, and the glass ball stem is either thick and curved or thin and plain. So there's an additional information given below the table. You can see that it states that the freezing point of mercury is negative 39 degrees Celsius, and the freezing point of alcohol is negative 112 degrees Celsius. The boiling point of mercury is 360 degrees Celsius, and the boiling point of alcohol is 78 degrees Celsius. So from the question just now, we can know that the temperature of North Pole is -40 degrees Celsius to -8 degrees Celsius. So which liquid used in the thermometer is suitable to be used at the North Pole? Is it mercury or alcohol? So we can see that the freezing point of mercury is -39 degrees Celsius. It means that the mercury in the thermometer will freeze at -39 degrees Celsius, whereas the freezing point of alcohol is -112 degrees Celsius, and it means that the alcohol will only freeze at -112 degrees Celsius. So you can know that it is better to choose alcohol because the lowest temperature of North Pole is -40 degrees Celsius, and the alcohol is lower than the freezing point of alcohol is lower than this temperature. So that if you choose alcohol, it won't freeze at the North Pole. But if you choose mercury, which is -39 degrees Celsius, it will freeze because it is higher than the lowest temperature of North Pole. So from the table, you can see that you can cross out the mercury ones. So you're left with S, T, and U, which is alcohol used in the thermometer. Okay, now let's move on to glass wall bulb. Should we choose a thin one or a thick one? The answer is we should choose a thin glass wall bulb is because heat can transfer into the thermometer easily, because if the glass wall bulb is thin, this is the glass wall bulb if you are not sure which part of it. We should choose a thin one is because heat can transfer into the thermometer easily. Because if it is thin, it means that it is smaller. So, and therefore it can respond faster to the temperature changes and provide an accurate reading for us. So it is better for us to choose a thin glass wall bulb. So you can cross out the thick one. So actually now you left thermometer T, but you still have to check the other characteristics. Now, the diameter of the capillary tube, should we choose a big one or a small one? Actually, we should choose a capillary tube with a small diameter. It's because when the diameter of the capillary tube is small, the liquid can expand quickly, or you can say rapidly, and it also makes the thermometer sensitive. But why is it like this? It is because the capillary tube produces like a greater change in the length of the liquid used in the thermometer, and therefore a small change in the temperature can be detected easily. So you can know the increase or decrease in the temperature easier with a smaller diameter of the capillary tube. So you cross out the big diameter of capillary tubes. Yeah. And after that, we look at the glass ball stem. Oh yeah, I forgot to mention that the capillary tube is the tube that is in the middle of the thermometer, which is used to fill the liquid, either mercury or alcohol. And the glass ball stem is the stem here. Okay, for the glass ball stem, should we choose a thick and curved or a thin and plain stem? We should definitely choose a thick and curved glass ball stem, is because if we choose a thick glass ball stem, we thick and curved glass ball stem, we can see the scale the scale easily, because if you see that the cross section here, it is like a circle. When we cut into half, okay, this part, is it like a convex lens? And do you all know what is the characteristics of the image produced when we uses a convex lens? It is one of it is magnified, right? So we get to see a larger scale of the thermometer. And that's why we should choose a thick and curved glass ball stem. So the best thermometer to be used at the North Pole is thermometer T, because its characteristics is the most suitable ones. Okay, now, if we are answering this type of essay questions, we need to create a table, and we need to label characteristics at the left side and explanation on the right side. You can either write explanation or reasons. And also you have to leave one column to write the most suitable thermometer that you have chosen. So let's see the characteristics. Liquid used in the thermometer is what? Glass wort bulb is, diameter of capillary tube is, and glass ball stem is. And after that, the most suitable thermometer is what? Because what? So the characteristics you can get from the table means these characteristics here, and the most suitable thermometer is you have to choose the best one, and because the reasons you can copy back from the characteristics you have listed here. Okay, so the first characteristic is liquid used in the thermometer is alcohol. But why? Alcohol has a low freezing point so that it won't freeze at -40 degrees Celsius. So as I have mentioned just now, alcohol has a lower freezing point than the lowest temperature of North Pole, so it won't freeze, and therefore it can still function well in the North Pole. But if you see mercury, it will freeze because its freezing point is higher than the lowest temperature of the North Pole. So it's better to use alcohol. And second characteristic is glass wort bulb is thin. And the reason is heat can transfer into the thermometer easily. If heat can transfer into the thermometer easily, it means that it can respond faster to the temperature changes and also provide us an accurate reading. Okay, the third characteristic, the diameter of capillary tube is small. And the reason is there are two explanations. You can choose either one. So the first one is liquid can expand quickly, or you can say rapidly. And the second explanation is you can say that it makes the thermometer more sensitive. And the last characteristic, glass ball stem is thick and curved. And the explanation is less heat is lost from the thermometer to the surroundings, and also a larger scale can be seen. So as I've explained just now, the glass ball stem we should choose a thick one so that less heat is lost from the thermometer to the surroundings. The heat is more difficult to escape from the thermometer. And if the glass ball stem is curved, it means that it can be used, acts as a convex lens and provide a magnifying effect so that it it produces a larger scale. We can see a larger scale, and also it's easier for us to read the temperature of the temperature of the object. And lastly, the most suitable thermometer is thermometer T because its characteristics are the most suitable ones. And because the liquid used in the thermometer is alcohol, glass wall bulb is thin, diameter of the capillary tube is small, and also the glass ball stem is thick and curved. So the reasons, you just copy back from the characteristics that you have listed here. So that's the end of our lesson today. Do you have any questions? So that's the end of our lesson today, and I hope that all of you enjoy today's class and it helps you, and hope that this class helps you. And before you leave the Zoom, I will please, yeah, you can see the chat now. There's a link given. So can you do me a favor, please? You click on this link and give us a feedback on our class today. If you have filled in the Google form, you can leave the Zoom. Thank you everyone for joining us today.